Welcome back. So last section we talked about functions. Now we're going to talk about, well, how do we graph these functions? So if an equation defines y as a function of x, we can sketch the graph of the function by plotting enough points to determine the shape of the graph and then drawing a line or curve through the points. This is called the point plotting method of sketching a graph. Now we're going to talk about a bunch of different methods of sketching graphs when it comes to lines. But the thing about functions is they're not always linear. So that's why we're going to look at the point plotting method to do this. So let's look on page 29 here. There's a really awesome box that I want to point out. So a graph is a complete graph if it shows the basic shape of the graph at important points on the graph, including points where the graph crosses the axes and points where the graph turns, and suggests what the unseen portions of the graph will be. Points where the graph turned from rising to falling or from falling to rising are called turning points. Very creative in math, I see. So what this is saying is they're basically coming out and saying not everything we're going to give you is going to be linear, which means that you have to make sure that you're getting the full graph. I'm going to show you an example here in a second of one where you really have to work to make sure that you get the full graph. But we're going to start off with an easy one first. We're going to look at number 4 on page 38. And I'm pretty sure I'm going to have to go to the whiteboard for this. So number 8, make a table of values for each function and then plot the points to graph the function by hand. Now, on your MyMathLab, you're going to have to graph using their graphing tool. If you find that you're having a hard time using the graphing tool, let me know and I can send out a video to kind of show you how to do it. It's not bad, but just be aware that you will be having to use the graphing tool. Okay, let's go to the whiteboard. Whiteboard, where are you? That's not the whiteboard. There's the whiteboard. Okay, the first problem that we're going to look at is number 4. Number 4. And they do give me f of x equals 2x minus 5. This is a linear function. And I know it's linear because your exponent attached to your x is a 1. That implies to me that it is going to be a linear function. So I don't have to work quite as hard to make my chart here, but just be aware that if it's not this pretty, you do have to make sure that you're getting enough points to be able to graph it. So I'm going to set me up a little chart. I'm going to have x. I'm going to have f of x equals y. And then I'm going to have x comma y. So I'm going to write out what my points are. Now, because we're using the point plotting method, you can actually choose whatever values of x that you want. If you wanted to use x equals negative 1 million and x equals positive 1 million, you are well within your rights to do that. The problem with using that, though, is that you have to draw lots and lots of tick marks. So what I suggest is make sure that you stay around your origin. So stay around 0 if at all possible. Now, sometimes you are going to have to move away from the origin just a little bit depending on what your graph is because it may be shifted to the left or the right or up or down. But this one, I like lines. We should be pretty good. I'm going to start with, let's do 0. So I'm just going to start with 0. I could pick some positive or negatives. I'm kind of lazy right now. So I'm going to pick 0. I don't know, 1, 2, 3, 4. Now, be aware, when you're graphing lines on MyMathLab, you're only allowed to use 2 points. So this is overkill what I'm doing, but I just want us to look at it and make sure that we understand what's going on. Okay. So if I take, or if I want to find f of 0, I'm plugging 0 in. So if I do f of 0, that's going to be 2 times 0 minus 5. So 2 times 0 minus 5 is negative 5. So f of 0 is negative 5. So I get a point of 0, negative 5. So I'm just going to take each one of these x values, plug them in independently into this function here, see what my y values is or are. So if I plug 1 in, 2 times 1 is 2. 2 minus 5 is -3. So I've got a value of, or a coordinate of 1, -3. I plug 2 in. 2 times 2 is 4. 4 minus 5 is -1. I've got a point of 2, -1. Plug 3 in. I get 6 minus 5 is 1. And if I plug 4 in, I'm going to get 3. Plenty of points to graph here, so I'm going to draw my coordinate system because I, unlike you, do not have a computer system that will do this for me real pretty, like my math lab. I could do it on Desmos, but that's another story. I'm just going to graph it by hand, so. As I mentioned before, we're going to learn a much easier method of graphing lines. I think it's actually in the next section that we do this. So let's plot what we know. We got 0, -5, 2, 3, 4. Here's the point. We've got 1, -3, 2, -1, 3, 1, and 4, 3. Now we are going to use our imaginations and we are going to pretend that I can draw a straight line on an iPad. Yep, there we go. There's our function. All right, let's do one that's not as pretty. So I'm going to clear this out. Let's look at number 8. So number 8 gives us the function f of x equals x over x plus 3. Okay, anytime that I have x's on the top and bottom of a fraction, I get worried because it's going to give us a split graph, most likely. So what I want to concern myself with here is in the last, I think it was 2 sections ago, we talked about this idea that when you get zeros on the bottom of fractions, it's bad. So if x was to be -3 here on the bottom, that would give me a 0. So -3 is going to be kind of the center point I'm going to focus on. So I'm going to have to pick some values that are smaller than -3. I'm going to have to pick some values that are bigger than -3 and kind of see what happens here. So let me make my chart out. And you are going to see me pick a lot more values than last time just because I'm not exactly sure what this graph is going to do. So f of x is y here, and then we've got x comma y. So -3, I kind of know is going to be the what I'm going to base everything around. And I do know if I plug -3 and I get 0 on the bottom, so that's undefined. And we'll talk about that in just a second, what that does. So let's pick some values. I don't know, let's do -6, -5, -4. That's smaller. And then I'm going to go let's do 2, or excuse me, -2, -1, and 0. So that should hopefully give us everything we need to know about this graph. So if I take -6 and I plug it into x here and here, I'm going to have -6 over -6 plus 3, which is -3. So -6 divided by -3 is going to be a +2. So we get -6, 2. If I plug -5 in, it's going to end up being a fraction. It does end up being 2.5 if you do the math for it. If I plug -4 in, I'm going to get out a +4. So we get a point of -4, 4. If I plug in -2, I'm going to get out a -2. If I plug in -1, I'm going to get out a -0.5 if I go through and do the math. And if I plug in 0, I am going to get 0 because I get 0 divided by 3, which is 0. So we got a point going through the origin there. Okay, let me draw my coordinate system. I'm going to keep on the negative side here mostly because that's where most of my points are. Okay, let's talk about this undefined right quick. This undefined, when you have this situation, this is going to create an asymptote. The way I like to think about it is like a force field that you can't cross. So I can have stuff on the left side, I can have stuff on the right side, but because it's a vertical asymptote, now be aware you can have horizontal and slat asymptotes. Those do a little bit weirder things than vertical, but vertical asymptotes you are not allowed to cross. So I'm going to switch colors here. Let's make it blue. I'm going to put a vertical asymptote by putting a dashed line up -3. Okay. So let's draw a graph here. Let's start with the -6, -5, -4. So I'm going to have -6, -2, 5, 6, -2. Here's a point. I'm going to have -5. Oh, wait, not negative, +2. My goodness, I can't count. 4, 5, 6. Here's +2. This is what happens when you have 2 children under 2. You just lose all capabilities of counting, saying your name. It's just all gone. -5 and 2.5 right there. And then we've got -4 and 4. So this graph actually looks like this. Well, I do a little bit better with curves on an iPad. So there's the first part. Now let's go look at the second part. So we've got -2, -2, -1, -0.5, and 0, 0. So it's the same looking graph, except it is flipped. So it looks more like this. Actually, I think the tail there needs to be, I think it does more like that. I think we got a horizontal asymptote at 1. All right, cool. Again, you cannot cross this vertical asymptote here. We're stuck with having graphs on both sides. These are weird graphs, and that's one of the reasons that they made such a big deal by putting that box talking about a complete graph. You want to make sure that you're drawing a complete graph. So just be aware of that. Let's do one more problem from this section. So I'm going to go look at number 40. So I'm going to get out of the whiteboard here. I'm going to go back to our book. Number 40, where are you at? Number 40, the unemployment rates as percents for the United States for selected years from 2000 to 2015 can be modeled by y equals -0.002x to the fourth plus 0.051x cubed minus 0.371x squared plus 1.055x plus 4.234, where x is the number of years after 2000. So on part A, we're asked to find what are the values of x that correspond to the years 2005 and 2016. One of the things that I want to point out here is that this is a very common occurrence in math. They're going to set a year as 0. So they're saying, where's my pen? X is the number of years after 2000. They're just trying to keep the numbers from being so large. So when they ask us to figure out what are the values of x that corresponds to years 2005 and 2016, they're asking, okay, well, if we're setting x, the year 0 as 2000, then 2005, which occurs 5 years after the year 2000, that means 2005 is going to correspond with x equaling, so 2005 is going to correspond with x equaling 5. 5. There we go. So when we've got the year 2016, if the year 0 is 2000, then the year 2016 would have to correspond with x being equal to 16. Again, that just keeps our numbers small. So in part B, we're asked to find the value of y when x equals 10 and explain what that means. So in part B, to find the value of 10, I'm going to have y equals negative 0.002 times 10 to the fourth plus, wow, this is going to be a long one, 0.051. I don't want that parenthesis there. Times 10 to the third minus 0.371 times 10 squared plus 1.055 times 10 plus 4.234. So I want to figure out what that's going to be equal to after I plug 10 in. Guys, all this is to punch it in your calculator and go. And if you do punching it in your calculator and work it out, you are going to get that it is 8.684. Now, I do want to mention that the unemployment rates were written as percentages. So when we say 8.684, this is actually a percentage. Okay, part C, what was the unemployment rate in the United States in 2015? So again, 2015 is going to correspond to X being equal to 15. So just like I did in part B, instead of plugging 10 in, I'm going to plug 15 in. So if you plug 15 in, you are going to end up with Y equaling 7.459%. And there you go. I do think number 40 is easier than trying to do the graph that we did for number 8. So yeah, it actually turns out the word problems can sometimes be a lot nicer than the other problems. All right, so that's all I've got on graphs of functions. The next video that we're going to cover is linear functions. So lots of cool stuff there. Lots of formulas. All right, see you then.